Hi everyone, what's up? Welcome back to my financial tutorial channel. Daniel's here and today I would like to talk about how to compare financial transaction. In the lesson today, first I'm going to introduce net present value, then U rate or internal rates of return, and the last thing is reinvestment rate. So, what is a financial transaction? A financial transaction could be an investment, a loan, a contract that your company issues exactly, which consists of a series of deposits, cash inflows, and withdrawals, cash outflows. For example, if Ted lends $1,000 to Donna today, and Donna promised to repay Ted $500 in 3 years and $800 in 8 years. Then on Ted's account, today he cashed $1,000 out. So that means $1,000 is cash outflows. Then 3 years later, he received $500. So $500 is the cash inflow at time 30. And 8 years later, Ted received $800. So $800 is another cash inflows. And to compare some different financial transactions, there are two important methods. The first method is we compare the net present values NPV of cash inflows and cash outflows. The second method is called IRR method, and we compare the interest rates, also called U rates or internal rates of return, implied by the cash inflows and the cash outflows. So let's take a look at the first method, net present values. So what is net present value? The net present value NPV of a transaction is the present value of cash inflows minus the present value of cash outflows. So NPV is summation of AT V to the T minus summation LT V to the T. Here we regard the cash inflows as coming from our invested assets. So we use capital A represent for asset, and cash outflows as payments we make on liability. So L represents for liabilities. So A is cash inflows and L is cash outflow. And remember on the lesson we learned about how to compute the present value. AT is the money at time T. The present value we multiply with V to the T. And similar for LT. And because the present value is a function of V, and V is 1 plus I to the negative 1. So NPV is basically a function of I, and I notate it as P of I. Example 2. Ted lends Donna $1,000 today, and Donna promised to repay Ted $500 in 3 years and $800 in 8 years. So here 1,000 is the cash outflow. So we and it is make today. So L0 is 1,000. L is the liability, and 0 mean the money is make at time 0. $500 is the cash inflows at time 30. So we have A30 is 500. And $800 is the cash inflows at time 8. So we have A8 is 800. So the NPV, the net present value of this investment is NPV is 500V cubed plus 800V to the 8 minus 1,000. Suppose the interest rate is 4%, then we can compute the net present value at I is 0.04 is find rate times 1.04 to the negative 3 plus 800 times 1.04 to the negative 8 minus 1,000. So the net present value of this investment at the interest rate 4% is 29.05. An alternate investment is that donor returns $550 in 3 years and $720 in 8 years for the same $1,000 investment. So here we choose the second payment plans, different payment plans. That is donor returns $550 in 3 years, not 500. And at time 8, he returns $720 instead of $800. So the net present value of this alternate investment is 550v to the negative 3 plus 720v to the negative 8 minus 1,000. And at the interest rate of 4%, we have the net present value is 15.045. So comparing the two investments, we see that the first investment gives higher net present value. So the first investment is more beneficial. So the first investment is better. So this is the first method to compare two different financial transactions. So here we have two financial investments, and at the interest rate 4%, the first investment has higher net present values NPV. So the first investment is better. Now we look at the second method, the IRR method, U-rate, internal rates of return. So what is the U-rate? The U-rate or internal rate of return, IRR, is the zero of the net present value of the investment. It is the interest rate at which the present value of the cash inflows is equal to the present value of the cash outflows. So to find IRR, we set NPV equal to 0 and solve for the interest rate I. So here go back to the example of Ted lending donor $1,000 today, and there are two available investments. The first investment, donor returned $500 in 3 years and $800 in 8 years, and the second investment, donor returns $550 in 3 years and $720 in 8 years. So at the first investment, PI is the net present value, and that is 500v to the negative 30 plus 800v to the negative 8 minus 1,000, and we set this equal to 0 to solve for I. However, this is a very complicated equation that we cannot theoretically solve these problems. So to find I here, we are going to apply a method called linear interpolation. So to apply linear interpolation to solve for I, we find two interest rates that make the net present value one negative and one positive. So here we plug in 4%. We have P of 4% is 29.5, but P of 5% is negative 26.61. So we are sure that there should be a solution between 4% and 5%. So we are going to use linear interpolation to solve for I. So by linear interpolation, we have 29.5 over 26.61 is equal to I minus 0.04 over 0.05 minus I. And solve this equation, we have I is 4.52%. So I repeat, to find I in this equation, we have to apply linear interpolation because this is not a linear equation is not quadratic, is not a simple equation of I. And to apply the linear interpolation, we have to find 2 points of interest rate. One makes the NPV positive and one makes the NPV negative. So the interest rate should be between them, and we are going to apply the linear interpolation. Next, investment 2. Donor returns $550 in 3 years and $720 in 8 years. So similar to investment 1, first we find the net present value function. So P of I is 550V to the negative 3 plus 720V to the negative 8 minus 1000, and set this this function equal to 0 to solve for I. And we are going to apply linear interpolation. So we notice P of 4% is 15.04, which is positive, and P of 5% is negative 37.57, which is negative. So there should be a solution between 4% and 5%. So by linear interpolation, we have 15.4 over 37.57 is equal to I minus 0.04 over 0.05 minus I. And the interest rate here, the yield rate here is 4.29%. So the I that makes PI is 0 is called the yield rate, or IRR, internal rate of return. Here, when we look at these two yield rates of the two investment, we notice that the first investment results in a higher interest rate. So investment 1 is more beneficial for TED. So investment 1 is better for TED. So that was how we compare to different financial investments. Now we go to a new interest rate, that is the reinvestment rate. So let's look at this example. You invest $100 in a fund earning 10% effective. You withdraw the interest earned at the end of each year and reinvest into another fund earning 5% effective. How much do you have total at the end of 10%, at the end of 10 years? What should be the yield rate of this investment? So the yield rate can also be understood as the rate over the entire investment applied when including any fee and any other transaction. So here, the first account earning 10% effective, and you invest $100 at time 0. You withdraw the interest rate at the end of each year. So at time 1, we have $10 is the interest and $100 is the principal. But you withdraw $10 the interest and reinvest into the second account. Then at time 2, from $100, you have another $10 interest. And the $10 interest at time 2 is also withdrawn and reinvest into the second account. So basically at the first account, at the end of 10 years, you have only $100 because all of the interest was withdrawn at the end of each year. So we should have only the principal left. So $100 at time 10, that's the accumulated value of the first account. Now we look at the second account. At time 1, we deposit $10. At time 2, we deposit $10 and continue to time 10. So we have totally 10 deposits. And this is basically an annuity immediate. So the accumulated value of the second account at time 10 is AV is 10S, 10 at 5%. Remember the second account earning interest at 5%. So, in short, at time 10, the accumulated value of the first account is $100, and the accumulated value of the second account at time 10 is 10S 10 at the rate 0.05. So the total accumulated value you have at the end of 10 years is 100 plus 10S 10 at the rate 5%, and this is 225.78. So now to find the yield rate, we look at what we invest and what we have at the end, and how long was the investment. So at time 0, you invest $100. At time 10, you have $225.78, and the investment lasts 10 years. So to find the yield rate over the entire investment, we have 100 times 1 plus I to the 10 is equal to 225.78. And from here we solve for I, and I should be 0.085, so it's around 8.5%. So that's how we find the yield rate over the entire investment. Next, example 5. $100 is invested at the beginning of each year for 10 years at 10% effective. The interest earned at the end of each year is reinvested at 5% effective. What is the yield rate over the entire investment? So this example looks similar to example 4. However, in example 4, we invested only $100 at time 0. But in example 5, we invest $100 at the beginning of each year for 10 years. So totally we have $1,000 invested. So $100 at time 0, $100 at time 1, and continue to time 9. So here's the time diagram. The first account earning 10% effective interest rate. At time 0, we deposit 100. At time 1, we deposit another 100. At time 2, we deposit another 100. At time 9, we deposit another 100. And the interest earned at the end of each year is reinvested. So at time 1, $100 earning $10 interest. So $10 here come from $100 invested at time 0. And this $10 is withdrawn and reinvest into the second account. At time 2, we have after $10 is withdrawn. At time 1, we have $200, $100 from time 0, and $100 invested at time 1. So at time 1, we have $200 after we withdrawn $10 interest. So at time 2, $200 accumulate to 200 times 1.1, and the interest is $20. And similar, so totally the first account we have the accumulated value is $1,000 because we invested $100 for 10 years at the end of each year for 10 years. And all of the interest was withdrawn and reinvested into the second account. So the accumulated value of the first account is $1,000. Now we look at the second account. At time 1, we deposit $10. At time 2, we deposit $20. And similar to time 9, we deposit $90. At time 10, we deposit $100. So this is basically an increasing annuity. So the accumulated value of the second account is 10 IS 10 at the rate 0.05. So the total accumulated value at the end of 10 years is 1,000 from the first account plus 1,000 times IS 10 at the rate 5% from the second account. So it is 1,641.36. Here we are using IS and formulas. So that is S double dot N minus N over I. And S double dot N is V to the N, 1 plus I to the N minus 1 over D. And D is I over 1 plus I. So I is 0.05 here, 1 plus I is 1.05. And this is 1 plus I to the N minus 1. N is 10. So the accumulated value of the accumulated value at the end of 10 years from both two accounts is 1,641.36. So here the yield rate, remember we deposit $100 at the beginning of each year. So to find the yield rate, we have 100 S double dot 10 at the yield rate I is equal to the accumulated value 1,641.36. And from here we are going to use BGN mode to find I. So the calculator note. First we set BGN mode because we're dealing with annuity due. So we press second BGN second set until on the right corner on the left on the right have BGN mode. Then we enter 10 is the number of payments, 100 is the amount of each payment, 1461.36 minus is the future value. Remember, because 1,641.36 is on the opposite side of 100, so they should have opposite side. If you set 100 positive, then 1,641.36 is negative. If you set 100 is negative, then 1,641.36 is positive. And then we compute the interest. So the answer is 8.844%. So that's everything about the lesson. Now we are going to work on some problem. Problem number 1, an industrialist is considering the purchase of a new machine for $50,000. If purchased, the machine can be used to convert $1,000 of raw materials at the beginning of each year into widgets that can be sold for $9,000 at the end of each year. The machine will last for 10 years and it is worthless thereafter. The required rate of return is an annual effective rate of 8%. Calculate the NPV. So here at time 0, the industrialist paid $50,000 for the machine. So $50,000 is the cash outflow. So that is the liability, and it's at time 0. So L0 is 50,000. Then the machine can be used to convert $1,000 of raw materials at the beginning of each year. So at the beginning of each year, we pay the industrialist pay $1,000 for raw materials. So at time 0, we have one more cash outflow, which is $1,000. And the machine convert $1,000 of raw materials at the beginning of each year into widgets that can be sold for $9,000 at the end of each year. That means at the end of this year, we receive $9,000, and the machine will last for 10 years. So here we have cash outflows at time 0. The cash outflow is 51,000. This is 51,000, not 50,000, because we pay for $50,000 we pay $50,000 for the machine and $1,000 for the raw materials. So L0 is 51,000. Then from the second year, the beginning of second year until the beginning of year 10, we pay $1,000 for a raw material. So L1 is equal to L2 is equal to L9, and this is $1,000. Now we consider cash inflows. So at the end of the first year, we will receive $9,000. At the end of the second years, we will receive $9,000, and at the end of 10 years, we will receive $9,000. So A1 is equal to A2 is equal to A3, continue equal to A10, and this is 9,000 for each. So now we are going to find the NPV. So the NPV is basically the sum of present value of cash inflows minus the summation of present value of cash inflows. So here $9,000 attempt 1, $9,000 attempt 2, and continue to attempt 10. So the present value of cash inflows, this year of cash inflow is 9,000, A10 at rate 8%, because this is basically annuity immediate. Then we subtract the cash outflows. $51,000 at time 0, so the present value of L0 is 51,000. Then for L1, L2 to L9, those money was make a time 1 to 9, so it's basically 1,000 A9 at the rate 8%, because it's annuity immediate. So now we compute NPV using calculator. So the first term is 60,390.73 minus 51,000 minus 6,246.89. The answer for the net present value of this investment is $3,143.84. An alternative solution for this is we are going to consider the net present value at the end of each year at time 0, time 1 to time 10. So at time 0, the net present value is negative $51,000, because at the beginning we should pay when we do not earn anything. So we have $50,000 paid for the machine and $1,000 for raw materials. So the net present value at time 0 is negative 51,000. At time 1 to time 9, the industrialists pay $1,000 and earn back $9,000. So the net present value at time 1 to time 9 is $8,000 for each. And at time 10, we do not pay $1,000, but we receive $9,000. So at time 10, the net present value is $9,000. And then we are going to use this with the calculator. So here I'm gonna show you how to solve the problem using calculator by two methods. So by the first solution, the NPV can be rewritten in the form negative 51,000 plus 8,018 plus 1,000 V to the 10. Because here if you add 1,000 V to the 10 into 1,009 8%, you have 1,018 at 8%. So if you subtract 1,000 V to the 10, don't forget to add 1,000 V to the 10. So net present value here is negative 51,000 plus 8,018 plus 1,000 V to the 10. So now to find net present value, we enter 10 as the number of payments, 8 is the interest rate, 8,000 is the payment of at the end of each year, and 1,000 is the future value. So this returns the present value for the last two terms, and then we add 51,000. Because here present value would be negative, so we add 51,000 and we have the present value, the net present value for uh, the whole investment. The second solution using the alternative solution. So we are going to use CF modes on BA second plus calculator. So to do so, first we have to clear work. And I repeat, and please note that before you start any problems, make sure you clear work on your calculator. So I'm gonna hit CF on the calculator, then second CE flash CE to clear work, and after that on the screen it's gonna appear CFO. So CFO is the net present value at time 0. So at time 0 is negative 51,000, so we have 51,000 and hit plus or minus to turn it into negative, and then hit enter. Remember, we hit enter, not equal. So we hit enter and then scroll down. So when you scroll down, the next information you have to enter is the net present value of the next time at the next time. So 8,000 at time 1, we enter 8,000. Hit enter and scroll down. So here they're gonna ask you for frequency. Frequency then means how many times you have 8,000 as the net present values. So here from NPV1 to NPV9, the net present value of time 1 to time 9 are all 8,000. So the frequency is 9. So I'm gonna enter 9, then hit enter and then scroll down. So the next net present value is 9,000. Right here. So we enter 9,000, hit enter and scroll down. And the frequency for this net present value is only 1 because 9,000 appears only one time. And then we hit enter and scroll down. Then we hit NPV. So when we hit NPV, the calculator will ask you for the interest rate. So hit 8, enter A, mean 8% interest rate. And then hit enter and scroll down. When you scroll down, they're gonna go back to the screen gonna show you NPV again. So you hit compute to compute NPV, and the answer should be 3,143.84. So when you deal with this problem on the exam, I suggest you to go by the second solution because it saves your time a lot. However, if you find the first method is easier, then just use it. Next problem. Susan deposits $8,000 into an investment account. After 4 years, she withdraws $5,000, and at the end of 8 years, she withdraws the remaining balance of 5,414.21. Calculate the effective IRR. So for these problems, I'm going to show you two methods to solve the problem. The first solution, the present value is basically 8,000 is the money that is deposited. So we have 8,000, and because it's at time 0, so it's just 8,000. Then at time 4, Susan withdraws $5,000. So $5,000 is the liability. So we subtract 5,000 v to the 4 because this money is made at time 4. Then at the end of 8 years, she withdraws the remaining balance of 5,414.21. So we subtract 5,414.21 v to the 8 because this amount of money is made at time 8. And here we are going to solve for v. So one thing you notice, this equation is a quadratic-like equation. So if you set v to the 4 as a new variable, let's say u, then this is basically a quadratic equation. So v to the 4 is using quadratic formulas. You have v to the 4 is 0.83856, and here we have v is 0.95694, and I should be 4.5% because V is 1 plus I to negative 1. So we take 0.95694 inverse and then subtract 1. We have I is 4.5%. Another way to find the answer is using calculator BA second plus. So again, we are going to use cash flows mode on BA second plus. So go ahead, clear word before we start the problems. So CF second CE flat C to clear word. Then $8,000 is positive and is make a time 0. So we enter 8,000 as CFO and then hit enter and scroll down. One thing you need to be careful here, at time 4, Susan withdraw 5,000. So from time 1 to time 3, there was no transaction. So we hit 0 and then scroll down and enter 3 for the frequency. That means from time 1 to time 3, the net present value is 0. And then at time 4, the net present value of 5,000, which is negative, because this is the liability. So 5,000 plus or minus, hit enter, scroll down, 1 for frequency, enter, scroll down, and then from time 5 to time 7, there's no transaction. So the net present value from time 5 to time 7 are 0. So we enter 0, hit enter, scroll down, 3 for frequency, because from time 5 to time 7 we have 3 years. So 3, then hit enter and scroll down. Then the last one is 5,414.21 liability. So we have 5,414.21 plus or minus, hit enter, scroll down, 1 for frequency, and then hit enter. And here, do not hit NPV because NPV is to compute the net present value. But this problem asks for IRR, so we hit IRR and then hit compute. And the answer is 4.499997%, which is 4.5%. Problem number 3, an investor pays $100,000 for a 5-year investment that produces cash flows of 50,000 at the end of 3 years and at the end of 4 years. So that means at the end of 3 years, he received 70,000, and at the end of 4 years, he received another $50,000. The cash flows are reinvested at an annual effective rate of interest 3%. Yield an annual effective rate of interest 7%. Calculate the net present value of 5-year investment. So here, this problem is a little bit tricky because the cash inflows will be reinvested at different interest rate. So here at time 0, the investor paid $100,000. That means the liability is $100,000 at time 0. L0 is $100,000. Then at time 3, he received $70,000, but $70,000 is immediately reinvested at interest rate 3%. So 70,000 at time 3 to time 5 is accumulated to 70,000 times 1.03 square, and the 70,000 that he received at time 4 will accumulate to 70,000 times 1.03 at the end of year 5, at the end of 5 years. So let's say V is 1.07 to negative 1. We have the net present value is first the liability is negative 100,000 at time 0. Then at time 5 we have 70,000 times 1.03 square, because this is the money that we have at we receive at the end of 5 years. So 70,000 at time 3 will accumulate to 70,000 times 1.03 square at time 5. And to find the present value, we time v to the 5th. And similar, 70,000 at $70,000 at time 4 will accumulate to 70,000 times 1.03 at time 5. And to find present value, we time v to the 5th. So the net present value here is $4,354.796. We also can do cash flows analysis. So at time 0, the net present value is negative 100,000. At time 5, the net present value is 70,000 times 1.03 square plus 70,000 times 1.03, and that is 146,363. And remember, at time 3 and 4, the net present value is still 0 because we received 70,000 and then we immediately paid 70,000. So the net present value at time 3 is 0, time 4 is 0, time 2 and time 1 are also 0. So we are going to use cash flows on a calculator. So first clear work, CF, second CE flash C to clear work. Then for the net present value at time 0 is negative 100,000, so we enter 100,000 plus or minus to turn into negative value. Then hit enter, scroll down. Then the net present value of time 1 to time 4 are all 0. So you have 0, enter, scroll down, 4 for frequency, hit enter again, scroll down. Then at time 5, the cash inflows is 146,363. So we have 146,363, enter, 1 for frequency, enter again. And the question asks for NPV, so we hit NPV. So after you hit NPV, the calculator will ask for the interest rate. So the interest rate here is 7%. Hit enter again and scroll down. And hit compute CBT, and the answer is 4,354.796. So on the exam, either you can use the first method or you can use the cash flows mode on a calculator VA Second Plus. Problem number 4. The net present value of the following two projects are equal at an annual effective interest rate of 8%. Project A requires an investment of $5,000 today. The investment paid $2,000 in 1 year and $5,000 in 2 years. Project B requires an investment of X dollars 2 years from today. The investment paid $2,000 right now and $5,000 in 1 year. Calculate X. So let's look at the first projects. The first project, Project A, we have $5,000 as the liability because that's what we pay for the investment. So negative $5,000. And then the investment pays $2,000 in 1 year. So that's the cash inflows, the assets. So we have 2,000 V. At time 2, the investment pay 5,000. So that is the second cash inflows. So we have 5,000 V squared because it's made at time 2. So project A, the net present value is 1,138.55 at the effective interest rate of 8%. Now we look at the project B. Project B, at time 0, the investment paid 2,000. So we have 2,000 at time 0. But you have to pay X dollars in 2 years. So that's negative X times V squared because this is the liability, the cash outflows. So negative X at time 2. So to find present value at time V squared. And $5,000 in 1 year is the cash inflow. So we have 5,000 times V. And this net present value is negative XV squared plus 6,629.63. And because these two projects are equal at the net present value, so we set these two net present value equal and solve for x. So we have xv squared is 5,491.07963, and don't forget v is 1.08 to the negative 1, so x is 6,400 0.79528. So that is how we calculate x, and we route to $6,405. Problem number 5. Susan receives cash flows of $100 today, $100 in 1 year, and $200 in 2 years. The present value of cash flows is 368.15 at annual effective interest rate of I. Calculate I. So we have 368.15 is the present value, so we set in the other side of the equation, or you can set negative 368.15 to the same side. And $100 today, $100 in 1 year, so 100V, and $200 in 2 years, so 200V squared. And from here, this is quadratic, so we are going to solve for V. We rewrite the equation into the standard form of quadratic equation. So 200v squared plus 100v minus 268.15 is 0. And v should be 0.93.46. Here v will have two values, one positive and one negative, but v cannot be negative, so we take only the positive answer. And from v we are going to find I. Remember, v is 1 plus I to the negative 1, so to find I, we take 1 divided by 0.9346, then subtract 1. We have 7% as the answer for I. Another way to work on this problem is use cash flows mode on VA second plus. So 368.15 is the present value. That means that is the money you have to pay for the investment. So 368.15 is negative because it's the liability. But Susan received immediate $100 today. So that means at time 0, the net present value is just negative 268.15. So we enter 268.15 plus or minus and hit enter and scroll down. At time 1, she receives $100, so we have 100 and then hit enter. Frequency 1, hit enter, scroll down again. At time 2, Susan receives $200, so 200 enter, scroll down, 1 for frequency, hit enter again. And this question asks for IRR, so we hit IRR and compute. The IRR here is 6.998959. So you have two ways to find the answer. Problem number 6. At a nominal interest rate of I convertible semi-annually, an investment of $1,000 immediately and $1,400 in 1 year accumulate to $3,000 at the end of 2 years. Calculate I. So let J be the corresponding effective rate of interest. Here we have I is the nominal rate, but because the investment is made year by year, not semi-annually, so I'm gonna call J is the corresponding effective rate of interest. And remember, in the lesson of measurement of interest, we are able to find I when we know J. So $1,000 immediately is what we pay at time 0. 1,400 is what we pay 1 year. So 1,400 V. This is equal to 3,000 at time 2, so 3,000 V squared. Another way to write this one is just NPV equal to negative 1,000 minus 1,400 V plus 30,000 V squared. So it would result the same. So here we are going to solve for V. So this is a quadratic equation. V should be 0.856, and from here we find J by take the inverse and subtract 1, so J should be 0.168. And now we have J, the corresponding effective rate of interest. So to find I, remember 1 plus I over 2 whole square is equal to 1 plus J. So from here I is 16.16%. Here I introduce two solutions to work on a calculator. Solution 1, we use CF, the cash flows mode on calculator. So first step, clear work. First thing first, clear work. Then at times 1, we pay $1,000. So 1,000 negative is the net present value of time. At time 0, we pay $1,000. So $1,000 negative is the net present value of time 0. Then 1,400 negative is the net present value of time 1 because that's what we invested. At time 2, we receive $3,000, so $3,000 positive, hit enter, and frequency 1. And we hit IRR to compute the effective rate of interest. So this is how we find J. So when we hit IRR, the question and hit compute, we have J. And to find I, we plus 1, and then take the square root, and then subtract 1, and then times 2 to find I. The second solution is using net present value cash flows analysis. So here, instead of using effective rate interest, we are going to use directly I, the nominal rate of interest, convertible semi-annually, but we are going to use I over 2 because I is the interest rate over a year. So it's semi-annual, it's half year, the interest is I over 2. So today is a time 0, we pay $100, so $100 negative, and hit enter for the net present value at time 0. Then at time 1 is basically half year from today, not 1 year from today. So the net present value at time 1, that means half year from today is 0. And the net present value at time 2 is 1,400 negative because at time 1 year later you invest 1,400. So 1 year later means 2 half years. So at time 2 we have 1,400 plus or minus, enter, and then enter frequency 1. At time 3, that means at time 1.5 years, the net present value is 0 and frequency 1. At time 4, that means 2 years from today, we receive $3,000, so 3,000 positive, enter, scroll down 1 for frequency, and then we compute IRR. So this IRR we turn into I over 2. The interest over is half year, so we times 2 for the interest over the whole year. So that's how we find the nominal interest rate of this problem. Okay, so that's all for today. Thank you so much for watching. I hope you guys enjoyed my video. This video I introduced how to compute. I show you how to compare. I show you how to compare two different financial investment. Next video I'm gonna show you how to approximate the IRR. Today we'll learn how to compute IRR, but sometimes we cannot find IRR theoretically. So next video I'm gonna show you how to approximate the IRR by two approximation: the time weighted IRR and the dollar weighted IRR. See you next time.